Right, hello. Right, Stream Manager, there we go. Right, hello people, Earthlings or whoever. I have got a fun project today that I'm going to work on. A while back I repaired a Revox A77 reel-to-reel tape recorder for somebody, and since then it has developed another fault. It's quite a beast, so I've got it on the desk already. My camera has decided it wants to twitch, probably because I'm on Twitch at the moment. Let me just see if I can stop that. Where's the zoom settings? There it is. Zoom and focus. Focus it. There we go. Right. Yes, it's quite a beast. So it's on the desk already. It barely fits onto my screen. But the problem that this has developed is one channel has lost all the higher frequencies. It's a two-channel system, has the ability to be single channel with mono and stereo and one channel, the other channel, whatever. And it just sounds so bassy. I'm just looking for the cables so I can plug it in. I've got my trusty audio input, universal input thing here. It's phono jack out on this. It's going to be hard to... Oh, it's so heavy. Hard to show you what's going on really. There is two phono outputs on the back here, which come out before the power amplifier for the speakers, and I need another cable like that. I've got one here somewhere. You can never find the cable you need when you need it, but when you don't need it you're always tripping over it. I've seen it recently, I've used it recently. No, I don't know where that's gone. A whole rack of cables under here, and it doesn't appear to be on anywhere there. Okay, I'm going to have to go into the cupboard. It's scary in the cupboard. Oh, I've got lots of cables here though. That one will do. It's a bit long, but it'll do. There we go. Okay. Let's plug that in there. That one into there. That's set to line. Now, I'm going to also need a power cable. Something else which I'm always tripping over, but then when I actually want one, there's none to be seen anywhere. Let's pinch one off here. Okay, come back camera, thank you. Right, that into there. Okay, now I'm going to have to see if it's going to be possible for me to get the audio for this into OBS somehow. For that I need to audio input capture. Okay, that might be working. Yep. Right, you should be able to hear this now. This is the reed head, and that sound when I, if it will, when I touch this contact, should give a nice buzz, but when I touch this contact, it gives only half a buzz. Unfortunately, I can't actually, let's turn this up, I can't actually hear anything on this. That's giving a lot of noise, that's giving no noise. Lots of noise, no noise. And if you play a tape on it, it just is so bassy, it's impossible to listen to. There's just no high frequencies at all. So what I'm thinking is that one of the amplifiers has died, basically. And chances are it's just an old capacitor has gone bad and will need replacing. But I'm going to have to try and find that capacitor, see which one it is, and try and diagnose it. So let's unplug this again for the moment. Oh, I don't need this connected. Oh. It is such a heavy beast. It's going to be almost impossible to work on. And I'm probably going to have to take it right out of the case to do anything, which will be interesting. This weighs an absolute ton. Right, I have already dug out, oops, wrong one, dug out the service manual for the Revox, which will help nicely. So we shall see what there is in there. I've had a look through it already, and there is a whole section all about the electronics, all the components, the board layouts, and it looks like it might be a very nice, simple, modular design with individual boards that just plug in, not even solder connections or anything, just plug in, which, fingers crossed, will make this very, very easy to work on. So my first job will be to get into it. Let's get some tools. So bring this view back up. I shall first of all want to get the main cover off. I have done this before when repairing it last time, of course. So, see if I can remember how we do it. There's 2 screws here. And here. And I've got a feeling it's been a while since I was last in this. I thought there was a 3rd screw. Oh, hang on, no, those, oops, ouch. Those are not the screws, these are the screws right at the edges here. Although I think those screws are also needed to come out as well. they're so long. Take the washer with it. Okay. Right, that's this front panel released. And I think I need to take these knobs off. To be able to get into it. There we go. Oops. Keep those together. I think that is... Is there anything else in here? Or was that it? I think that's it, and it's just clipped now. Yes. This front panel pops off. There we go. I need to take it off without the rest falling apart, although this I think also now just clips. There we go. And that all comes away. Right. We are in. There's the beating heart of the Revox. Now I think I'm going to have to remove all of this from here in order to get to the circuitry, which is all, of course, underneath. So the removal of this, I think I should take a look at the service manual. I don't like having to resort to such things so soon, but I don't want to damage it. Removal of housing, removal of cover panel, front panel, power switch, brake unit. Let's just take a look at page 6. That's the chassis there that everything is all built onto. Dismantling. Yep, remove those 4 screws, I've done that. Remove the housing. Set instrument face down on soft basis. Remove a remote control dummy plug. Remove housing fasteners. Pull housing carefully upward. Disconnect loudspeaker connectors on regulator card in the carrying case. Reinsert remote control plug. Bridge power disconnect jack with 2 insulated banana plugs. Okay. So I need to turn it over and put it on something soft. And that doesn't mean my brain, which is pretty soft. I think I know the perfect thing. Let's just switch back to the desk view. Here's a couple of nice soft pillows. Should do nicely. Yes, first I think I'm going to remove these buttons, which are liable to break if I'm not careful. And if I remember rightly, they just pull out easily enough. Okay, that should be pretty stable. and we turn this over, and there are, that's the remote plug, which without it won't do a thing, because the remote control for this is on a cable and sort of goes in line with the controls, so that just bypasses the remote control. Okay, Phillips screwdriver, 4 screws on the base. One, 2, 3, and 4. Remove the housing fasteners, pull housing carefully upward. Yes. Disconnect loudspeaker connectors on regulator card. Oh, sorry about that. The handle on the cover. Okay. We are in. And I'm going to turn this around. Oh, so that you can see the electronics. Oh, look at that. Individual cards for each function, and yes, they are all in these little green, you see it best on this one, green sockets. So they all pull out. Right, and from what I read in the manual earlier, let me bring that up again. My desk is now rather full. Where I capture the boards that I want. It even shows you which board is which. No, where are we? There was I'm sure I saw earlier a map of which board was where. Scroll back up, sorry if this is doing anyone's head in at the moment, but trying to find things in this manual can be tricky. Here we go. So we've got the map here of the boards. So we've got the input amplifier on the end, then we've got the record amplifiers for the 2 channels, 1 and 2, and the oscillator in between, along with the record relay and the playback amplifier. That looks like the ones we want on the far end. The playback amplifier cards each contain 1 playback preamplifier and 1 drive amplifier. The playback head is DC coupled with the input stage. DC feedback from the emitter voltage divider of stage Q82 goes over the playback head to base Q801 and stabilizes its quiescent point. Blah blah blah. So yes, that looks like what we want, which is these 2 here. Channel 1 is that one, which I believe is the one that's faulty, and channel 2, channel 2 is the okay one, channel 1 is faulty. That's great. Having them on separate cards like that, having these on separate cards means I could just take them both out, swap them over, plug them in, play a tape and see if it's improved that channel. That would confirm it. But having them on separate cards also means I can compare the two. So it should be as easy, I hope, as just lifting this out. There are no fastenings on it anywhere. It doesn't look like it. It's I see, it goes underneath this lip here. So we'll have to pull it forward somehow, or take this back plane off. Right, yes, the back comes off easily enough, I think. It looks like there's just a couple of screws on the back here, which will then allow me access to the boards. Just check on the stream. Yep, okay. So that should now hopefully lift off and over a bit. Oh, there it goes. It just pulls off. That's nice. You can now see all the nice circuit boards. Oh, interesting. This has obviously had some work done on it in the past, because that's a different pot to all the other pots. Right, that's interesting. That is interesting. So that's an identifying feature, but also let's go a 1 on there and a 2 on there just to mark them. So easy to work on. Just unplug it. That's channel 1 and that's channel 2. I am going to, I think, switch these over just temporarily and just see what effect that will have. But I don't know, because I'm going to have to rebuild the whole thing to get it going again now, aren't I? No, I won't. It's a lot of effort to go to just to test it. So I shall take these out. These are the suspect, or one of them, this one here is the suspect one. So now I don't need this great heavy weight. It can be removed and put down on the floor. Oh. I can get rid of these pillows. Right. Now I'm going to have to focus my camera again. Where's the focus setting? There we go. Zoom in a bit as well. Right. Back to the desk. Okay, so what do we have here? Is there anything that immediately jumps out at me as being faulty? No. There's only these 3 electrolytic capacitors. So if it's going to be a capacitor, it'll be one of those 3. There are a couple of tantalums, at least 4. Interesting, they've got different coloured. But the boards are different colours, so I'm wondering actually if one of these boards is a later one from that's been put in from a different machine or has been replaced at some point in the past. It's possible. The solder all looks fairly good. 1077.720, one 077-01. Yep, the revisions and everything are all the same, so there's no design differences between the two circuit boards, but they're obviously of different ages. The colours are different, the mask is different. So different ages or different batches or different manufacturing plants. I'm not sure. There is a slight other difference. This has got 2 extra holes at the top, which this one hasn't got. Interesting. Right. So the great thing is, by having them 2 identical boards, it means that I can test components in circuit that I wouldn't normally be able to test, because I don't really care what the values themselves are, just comparing the values from one board to the other. So if I were to go to a capacitance test range and, for example, test this capacitor here, that's giving me 2 microfarads. No, 2 millifarads that's giving me. 2000 microfarads, that would be. It's supposed to be a 1500, but yeah. Then compare that to this one and see what we get. That's giving me 2.6 millifarads. So that is actually showing a different... and the 2.6 is irrelevant. It's comparing the 2 that is important. 2 against 2.6, that's quite a difference. We shall try this one, which is giving me 100 and... it's flashing around a bit. It's because it's in circuit. Measuring is silly basically, but that's flashing around to 171, and this one is flashing around to 178. That's okay, they're both about the same. These at the moment are showing more difference than I would like. Then we've got this one here. This is positive this end, although just for measuring it's not that important. On here I'm seeing 25 microfarads, and on this one 24.1 microfarads. Come on, 24, yeah. So those are also close enough. There is enough of a difference between these two for me to suspect that this capacitor might be possibly slightly iffy. Possibly. I mean, that reading of course might be being changed by another component around it. These resistors normally, this style normally don't go bad. They're usually okay, so I wouldn't suspect these resistors. Tantalums, not really, no. Yes, they do fail, but when a tantalum fails, it normally fails with a short circuit, which I suppose might have happened. So I guess I should really go around and test them. What do I get here? 14.5. 9.6. Iffy. 3.8 against, come on, 3.3, yeah, that's all right. This one up here is an easy one to get to. Let's try that. 3.6 against 3.4, yeah, fair enough. Can I get into this one down here? This is an awkward one. 140 picofarads. That seems very low for a... There we go, 3.8 against 4.5 here. I mean, it's not too bad. I would expect it to go on, be completely wildly different if it were a dead tantalum. And we can do a continuity test on these just to see if there is a short. But nothing yet there, no. I'll just check this one as well, just in case it's not the right board. That's all okay. That's fine. So it still is looking at the moment like it might be that that one capacitor there. The other possibility is the trim pot here, but I don't think so. That's 25. That's 16. 16 against 25, but it depends how it's being used. The value might be irrelevant. 23 on there and 15 there. So yeah, if it's being used as a sort of divider, adjustable divider, then the actual resistance values aren't relevant, just the ratio between them. So I mean, I think that's all okay. What I would like to do actually is properly test one of these circuits. Let's take that off. Don't need the DMM anymore. Where have we gone? Let's see, there, that one there, turn that off. Because what I can do is I can power these up separately outside of the unit and inject an audio signal and trace that audio signal through and see where it drops out. Do the same on both boards to get a good comparison. Let's bring up the schematic for this board. I shall just skip through and find it before bringing it up, just so that I don't melt your brains with flashing past images. Right, and we want that one there. Okay, so this is C803, this big capacitor, and that is 803 is down here, which is on the input going to ground. Let's have a look. We've got that a resistor and then a capacitor to ground, so that basically makes a low pass filter there to ground, so that's a lower frequency there. Right, 803, 1600 microfarad. On here it's, yep, 1600. But this was showing us considerably more, which usually means that it's leaking. If it's leaking, then it's finds it harder to charge it up when testing, so it thinks it's higher. So yes, that does bode for that capacitor. But what we do get on here is what all the pins on the edge connector do. So we've got, it's going to be awkward, 19 volts and 21 volts between the two pins there. That's, I've only got one power supply, so I can either have 19 or I can have 21. Although 19 volts is the voltage used by laptops. So could I get a laptop power supply to power that, and my bench power supply for the 21 volts? Or why is it you need those two specific voltages though? The 21 volts is just for the output stage, and 19 volts is for the rest of it. I mean, surely I could just power them both from 19 volts. But if I don't need the output stage, I wouldn't need to power that immediately. So actually I could do it in two parts. Because you've got the input stage here. That's the input stage, which then goes out to the switches which switch between which channel it is. That then comes back in to the output driver stage. So I could do it in two parts. I could just power the input stage and the first stage of the output from the 19 volts to test this portion of it, which would then give me the output through here, through pin 8. Possibly. And then try powering the whole thing from just 19 volts on pins 6 and 9. Might work. But certainly I want to test the input stage first as a separate thing. Now, how am I going to best connect to this, given the style of connector? I don't have this connector. What I do have is I've got this connector, which might work or might not work. It's a different pitch, but if I can get the pitches to coincide enough so that they contact but don't short circuit, that might do the job. Because this can just push in quite happily. I mean, it's just a standard edge connector. It's just the pitch of it. This is a 0.1 inch pitch. This is actually what you use on the edge connector of the Amiga 500. So if this can line up, unfortunately it's not going to work. It's exactly 1.5, isn't it? So if I have that, hard to see on here actually. But if I have that lined up, the first one lined up, the next one is exactly halfway between and right on the ridge between. So actually that might work out. possibly, if I line that up exactly on there, and then push that in, aligned to there. Right, use this as a reference. This is the iffy one. Let's beep this. If I'm right, this pin here should connect to here. It does. Then this pin here should connect to here. It does. And this one should also connect to here. But this shouldn't connect to here. Bingo. This one is on that, but doesn't go to that. That one is on there, as is that. No, I've got... Oh no, that's... No, yes, no. Hang on. That's... No, that's not quite lining up. I appear, unless I've got... where are we? That's from there. Going through to there. That's here. 1, 2, 3, 4 I've got there. So unless that and that do connect, which they don't, no, that's... Oh, actually, they do. So that's 1, 2, 3 and 4. 3 and 4. They do connect, but... Well, no, they don't connect, but there is a capacitor, a large capacitor between them. Of 1,000, no, it's not that large actually, 1,000 picofarads, so that's nothing really. So we got 1, 2, 3 and 4. 3 and 4 on the schematic. 3 and 4 are these two here. Which are to do with tape speed. And change the filtering in some way. Yes, but when you change the tape speed, you want to change the response curve. I'm thinking that's the equalizing. But I wouldn't expect that to be showing as an actual short circuit. Maybe it's just enough to make it beep. 0.22 ohms, no. That shouldn't be 0.22 ohms, I don't think. No, hang on, it must be. Because this is the working card, so it must be 0.22 ohms. Between 3 and 4, we have a 4.7k resistor. We have a capacitor and 6.8k resistor to ground. We have an 220 ohm resistor to ground. Well, I'm not sure on that. But, well, regardless, I'm not happy with it because, yeah, we get 1 and 2 together, which would be the actual pin for this. Then a third and a fourth. So no, I don't think it is lined up quite right. We shouldn't be getting that fourth. Thing is, when you push it in, it's hard to keep it from sliding, and I can't put it right against the end stop because it's not quite aligned. Although, actually, against the end stop, it's aligned halfway. So actually, yeah, if I put it right against the end stop, okay, the first one is 1.5. So I've got those two are connected, which goes to that, but not that, which is to there. Then that's clear, which goes to there and there. That's then going to that one through whatever means. No, we're still getting the... We're now getting 5. So we've got paired, single, paired, single, paired. Right. Ooh, let's just try something. If I put this one in instead. So you've got paired, single, and you've got paired, which also goes to that. No, that's going to all of those. It's going to all 5 of those. That's 3, 4, and 5. But then that's all this same... let's clean this up a bit. That's all this same section. Three, 4, and 5. It's this set of connectors here that all come from the same sort of area. But between 4 and 5, I expect 2.2K. All this is external to the board. But this resistor here, between 4 and 5, the only connection between 4 and 5, other than going through all the rest of the circuitry, including capacitors to ground, is through 2.2K there or 4.7K that way. So I would expect this connection 4 to 5, 0.23 ohms. What if we turn it round? Is there a diode effect going on? 4 to 5, no, 0.4 ohms, 0.6 ohms. Okay, so why is that giving such low readings? That's on the iffy one, and this is on the good one. Between 4 and 5, 0.25 ohms. Okay, thoughts? Anybody? Let's bring the schematic up for you again. Between 4 and 5, it's almost like that switch exists, but let's do it on it. It's almost like this here switch exists in circuit but doesn't. As far as I can see, the only way to get anything from 4 to 5, it either has to go through a 2K 2 ohm resistor that way, or it has to go through a 4.7K ohm resistor that way. It's either going there or it's going there. So how we can be measuring from there to there 0.2 ohms. I'm confused. I am definitely going from the right end here, which is pin 1 is the wider end. That's the key there, the gap. One and 2 are the input. 3, 4 and 5 are the output here, which come to crosstalk compensation from channel 2, which is feeding back. This is where it gets a little complicated because you've got this feedback. I hate feedback. So you've got the signal comes out here, comes down here, and then it goes through these two, one of these two equalization circuits, depending on the position of this switch here. But that position of the switch also then affects whether this connects through to here, and then the tape speed defines whether that connects through to here, to then feed back into here. So I'm not certain if this is actually shorting or not. I don't think it is shorting. If I push that in like so, go back to beep. So we should have paired, single, paired, single, paired, single, then paired. You can't see what I'm doing, can you? There we go. Paired, single, paired, single, paired, single, paired. Hang on, go paired. That should be single then, from there to there. Then that should be paired to single, and then paired. So we've got paired there. It gets a bit more tricky now because of the gap. Oh, hang on. No. Of course. Paired, single, paired, single, paired, single, paired, single, paired, single, paired, single. Then that should be that should be paired there. By that point, I should be pairing on that. So I think I've got enough drift on this now that it doesn't quite match up enough to contact. What is that one? That one is pin 13. Pin 13 is coming right up to the top here and going to that. Oh right, that's here. Which is output through there into that feedback and the connection down through the switch. So that's, yeah, that pin 13 is kind of important because that is the major part of the output of the first stage. So yeah, I kind of need pin 13. Right, what other options are there for connecting to this? So I certainly don't want to solder to it. Although, I mean, I could solder to various points on the back. But I certainly don't want to solder to the edge connector because that would mess up the actual connection. And I want to be able to swap them as well. So I really do want connector. Just wondering, do I have anything? I don't think I do. Let me just get my box of random connectors. I'm not aware of having anything at all in that sort of pitch. No, I've not really had any call for those kind of connectors. And basically a 5.04 millimeter pitch card edge connector. No, I don't have anything. There's nothing spare in here, is there? No. Nothing in the actual machine I can take out. No, I think I'm going to have to resort to soldering. Let's put these back on the shelf. I mean, realistically, all I need is the 19 volts for the power, the ground. I'm sure I can just inject one signal there on pin 1 and an output pin 13, I think. So yes, realistically all I need is those 4 pins. So yeah, I'll just solder a couple of wires to them, I think. Come back, camera. Hello. It does like to wander off by itself. I'll see if I can use a couple of like DuPont connector jobbies. Thousands of these, literally thousands, a whole bag full of them. But you can never find the one you want, can you? Alright. That'll do nicely. I've got those, and I need one more colour. Blue, that'll do. Okay. Right. So this is the good one. I'm going to have a look at the good one first, I think, actually. So I've got a baseline to work from. So pin 6 is 19 volts. This is pin 1 here, so 1, 2, 3, 4, 5. Pin 6 here is the 19 volts, which comes up here to here and here. That's trace it round, it goes to there and there. Okay. So if I were to just solder this pin on to here. Okay. And ground is ground is pin 8 apparently. Let me just check that on the schematic. Where is pin 8 on the schematic? 3, 4, 5, 8. There it is. Yes, there's a dot on there, isn't there? So 1, 2, 3, 4, 5, 6, 7, 8. Yes, that goes everywhere. 1, 2, 3, 4, 5, 6, 7, 8. It comes all up here to here. There's a good one. Let's go there. That's ground. Okay. Right, input and output. Now, actually, do I want, or do, because I'll be probing. No, I'm not going to connect the input and output actually, no. I'm going to put a probe on each of those. So that I can do some tracing. Right, I'm going to need power cable, which I think is up here. There we go. And hope it's long enough. Up to my power supply. This needs to be 19 volts. No idea how much current. I'm going to limit the current, I think. 100 milliamps. I don't want to do any damage, so 19 volts, 100 milliamps. Turn on my scope and my waveform generator. See if I can get the scope up. No, come on scope, where are you? Scope isn't running, okay. Let's try that again. Oh, unable to open DSO, why? Okay. That looks all right. given it as root. Oh well, there we go. No, it's still not showing, but it's showing as working now. Okay. Oh, there we go. Right, we're back. Right, so let's zoom this in a bit. So we'd be expecting, according to the schematic, an output in the order of 20 millivolts. So let's set this to 10 millivolts per division. Let's create a sine wave of not 1 megahertz. Let's go 800 hertz. That's a normal test frequency. Okay, output on. Let's just see that we're getting something out here. Oh, hang on. Amplitude needs to come right down 0.1 volt peak to peak. Let's get a take that down, 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 down. There we go. Just holding them together is so noisy. There we go. Right. And we're right. We'd be expecting what sort of voltage? I've got 0.6 offset there. So we'd be expecting a very tiny voltage going in. So I'll set to 5 millivolts peak to peak with it might need a DC offset actually of, if that's going in from there, there'll be a 0.6 of a volt offset. Okay, oh hang on, I've got that. Where are we? Channel 1. Yeah, there's AC couple that. Okay. Let's turn off the measurement. Cursor off. There we go. We've got a lot of noise in there at the moment, haven't we? Anyway, right, so we're generating a signal 800 hertz of 5 millivolts with a 600 millivolt offset on that probe. We're measuring on the oscilloscope on this probe. There we go. So let's apply 19 volts to this. Okay, it's drawing no current at all. Constant voltage, output on, yeah. So that's drawing no current. So we have the input. This is where it gets a little tricky, trying to get all the grounds connected up to the same bit. That might do the job. Actually, let's pull the insulation back a bit on this if I can. I can't. So let's go this way around. Take that onto there, then that on to there, and that onto there. Will that do the job? Nope. Onto there. There we go. Okay. Let me just check the voltage on here. So from pins 6 to 8. 1, 2, 3, 4, 5, 6 to 8. 19 volts, yep. So we have power going in. Let's have a look. The output would normally come out on pin 13, which is here. There's certainly something there, because I just saw it jump up, come on. Okay, and the input would be on pin 1. I wish I had another 3 or 4 pairs of hands. There we go, there's our signal. Coming through nice and strong. That's good. So that's the sort of signal we'd expect from there. Oh, and I've lost my ground connection again. I don't like these clips, especially when you're trying to get so many of them in together. Oh, hello. Come back, thank you. Right. So that is looking okay. Let's just solder this one up the same way. I shall use brown for ground on here and blue for power. So power goes to here. Yeah. No, that's power. Brown for ground I was using, wasn't I? That's to there. Remember that ground is the colour of soil. And the blue one onto there. Remember, we're just testing the first stage of the amplifier here. So I want blue on there. This is the channel 1. I think it was channel 1 that was the faulty one from my earlier tests. We shall find out once I've finished testing everything. Okay. Pin 13, the output is there. That's my hand causing that, I think. Must be an easier way of connecting to this one. That's up to there. Okay. And the input is to there. Ooh. Input is to pin 1. Pin 1 is this end. Oh, there's certainly something happening, but I'm not seeing our signal. Um, 13 is the output. That's 13. That's 1. That's definitely showing different behaviour. Right. there's our signal. I'm getting nothing from there. Let me just double confirm with the other one. Make sure I did do it right before. Ground and power. Let's do this one in the same way. Output is 13, which is there. Input is 1, which is there. Ah, hang on. I'm not getting anything now. Right, I think I must have done something wrong before. Got a feeling my ground connection might have popped off or something. Okay. It's complicated by having that in circuit. I wonder if I inject straight into the base of Q802. Q802, let me just bring the schematic up. Because I'm looking at the moment, let's clean this up. All this scribble. Ocular really needs a select all, doesn't it? Let's take that out. There we go. Right. What I'm looking at is, at the moment I'm trying to inject into here on pin 1. And then measure on pin 13 here. I'm wondering if I try injecting as a... Well, if I'm injecting on pin 1, if I check that point just there, I'm going to add another wire onto pin 1. Just to make life easier. Because I want to inject on pin 1 really. Pin 1 is this end here. And yellow is the injected signal. Oops. Something just short-circuited then as the power fell off. Hopefully just a touch of that to there, which just goes straight through to ground. That's why I always run with a very much limited current, so that in case of an emergency like that, nothing happens. It just switches itself off. Okay, so we have our signal coming in here. Let's get it to where you can see it. Our signal coming in here. All our grounds are connected up and working, which then goes these three here. Let's move that out of the way. These three here are the transistor. If we look at the layout, we're looking for Q801, which is Q801 is, there we go. Q801 is here, and the collector of it goes to the base of Q802, which is the one right next to it. So we've got that there should be the yep, that's going through to there. So the output, hang on, have we got that? To there, to there, to there. That's, if that's the base, no, hang on, where are we? No, that's going through to here. No, hang on, we got, ah, no, I'm looking at the wrong. So we've got, it's awkward working on this side. That's there, so we've got, that goes to the mid one there, so yeah, that, there, okay, I've got it. You've got this triangle here for one transistor and this triangle here for the other transistor. So that's one pin of the transistor, that's the other pin, and that one there should give us a signal-ish, kind of. This one is the good one, apparently. It does give us a signal, but it's very small. Okay. What I think I shall do now, let's change the type of signal to noise. Okay, so I've just got noise coming through. That's just noise. So if I now look here, just noise, and here, just noise. Now, through the magic of this system, hopefully, if I do this, I can no, I've never really tried this. FFT channel 1 URMS. No, I was hoping that I might be able to get an FFT output of it to get a frequency response, but this oscilloscope is somewhat lacking in that regard. Actually, let's switch back to sine. I am seeing a little something, I think, right at the very bottom edge of the thing. It's not exactly sensitive, this system. So no, that's worth a try, but no, it doesn't. Let's see if I can stabilise this a little. No, it's not going to stabilise. It was worth a try. I was hoping I would get a bit of an FFT output to give me a bandwidth plot, which would have been very useful later on when it comes to working out where the signal is degrading. I need another wire for the other board. Try and pick a colour I haven't used yet. Purple. There we go. Let's take this board and pop a wire on pin 1. Okay, so ground goes here, power goes here, signal goes here, and we have our signal is coming in here. It's after the first transistor and the second transistor. That's showing just the same there. Okay. Let's go for, let's try parameters, offset. Let's take out the offset. I don't think we actually need that in there, do we? Actually, we might do. Let's add the offset. Keep the offset in there. 600 millivolts. Amplitude. I'm going to take the amplitude up a bit. That's looking good. 50 millivolts. Okay. There's a lot of noise in it. Okay, frequency. Increase the frequency, and for the major part we shouldn't get much drop off. 4 kilohertz, yeah, 6 kilohertz, 8 kilohertz, 10 kilohertz. Now we're starting to see a bit of attenuation at 12. Take it right up. 21, yeah, that's fine. You wouldn't want more than that. So that, at that stage, is responding perfectly well. Let's just check the other one. And the output of that transistor, come on. It's such a tangle with these probes. Where on earth is that going? Let's take that off. Okay. Right, so on the output of the second transistor here, which is there, it's a bit noisy, but that's me mainly, and crank up the signal frequency 17, 18 and 20, a bit of extra drop off there, but not enough really to be of any concern. So the first stage looks to be perfectly good. Right. That's interesting. The first stage is working and appears to be responding perfectly. So let us think on. Right, so that big capacitor was C803. C803 is in the first stage, so that shouldn't then be faulty. It was reading high, so it might be leaking. So it might be affecting things a bit, but it doesn't seem, that first stage seems to be okay. Certainly as far as here, this point is responding okay. I mean, I could take it all the way to pin 13 to test the frequency response. That might be worth doing actually. Take it all the way to pin 13 and test the, because you've got these extra bits of filtering here, these inductors and capacitors. So let's, yeah, I shall do that. Let's connect this one back up. Back to desk view. I want this connected to here. Power to here, okay. Pin 13 goes to here. We're currently on 7 kilohertz. Got quite a bit of attenuation there, but that's caused by the trim pot there. So actually I'm going to, let's turn that up. A lot of noise in there. Alright, we're on one, let's start at 1 kilohertz. And a lot of that's caused by the inability to ground, noisy probes. And an oscilloscope as well. Okay, so we are at that sort of level. If I bring this up to 20 kilohertz, we're seeing no real attenuation there. That's good. Then we go for the other one. Signal in, ground, power. Oops, don't short circuit those. Oof. Okay, and output is really noisy because I'm touching it. Problem with working on amplifiers, if you touch it, you inject your own noise into it. So on 1 kilohertz at the moment, and crank it up. 20 kilohertz, that's looking reasonable to me. Noisy but reasonable. Okay, so I can confirm first stage right up to pin 13 is working fine on both boards. So next stage is the next stage. I can move these annotations. So now the next stage comes in on pin 7. Goes in on pin 7 into here, and then you have a 2-stage power output stage. Now this is where it gets a bit more complicated, because apparently I need 19 volts and 21 volts, but I'm going to just try powering the whole thing from just one single 19 volt supply. And for that, I'm going to need some more wires, I think. Let's have a look. I've got there's a white one and a yellow one. So we've got pin 9 is 21 volts. Pin 9 is 21 volts. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. The one away from the gap. So we've got there, which is, yep, that's the collector of that transistor. And we've got there, which is that 10k resistor. I'm thinking we'll go to that 10k resistor there. Okay, let's tin this. That's a convenient place for there. We shall do the same on this one. Which is here. There we go. And we inject on pin 7. So I shall move this green one here off pin 1. 1, 2, 3, 4, 5, 6, 7. That is here. Taking care not to short with pin 8, which is ground. So pin... Come on, off you come. Pin 1 moves to pin 7 here. Okay, that's fixed. Okay. So now this is the good one, or channel 2, the one, if I remember right, is good. I've got my convoluted ground clips. I've got my input signal. I've got power ground. My power signal needs to go to both of these. Try and do it so both get connected at the same time. Not very good connection, that. No, it does not want to connect well. Actually, I'm going to just put a spot of solder on the ends of these. There we go. Connect that up. That's actually drawing a bit of current now, 0.007 amps, 7 milliamps. That's a better sign for a power amplifier stage. Okay, so here's our input. Oh, let's switch to the other view. Here is our input signal. Come on. Which is far too big at the moment. Bring this down. Actually, I need to take the offset down to 20 millivolts here. That's better. Take the amplitude up, and there we go. Much cleaner signal, 80 millivolts, that'll do. Okay, that's our input signal now. So this goes, first of all it goes through capacitor and resistor. This is, goes through 3.3 microfarad capacitor, that's this tantalum. And then that goes, you on this side, through that resistor there. Okay. Into here. Then we have transistor, that's going into base of that transistor. Collector is there, and that's, oh, massive clipping going on there. Let's turn down the amplitude. We've got far too much volume going in. And I think it doesn't like our offset. Although, actually, the offset would make no difference whatsoever because it's AC coupled, isn't it? So, there's quite a bit of distortion in the waveform there, isn't there? Let's take the frequency up. I'm interested in amplitude really here. So 10, we are 400 millivolts peak to peak. At 15, we are down to about 200. That is quite a lot of attenuation there as the frequency goes up. That's interesting. That is the kind of effect that we were experiencing with the actual tape playback. Right, so this might be the faulty channel, and I might have just found a test point for the problem. Interesting. I'm going to have to try the other board now. So again, I want to just put a spot of solder on these just to hold them together. Actually, that distortion that we were seeing might be because of the common voltage power supply between the two portions. rather than a split 19-21 volts power. Or it might be a symptom of the problem. There might be no distortion on this board. Connect the power, okay. And our input signal is there and tiny, goes through that capacitor, through that resistor, up to this transistor, somewhere there, is it? Or was it there? No, hang on, confused now. It's that's that capacitor there going to there, so that to there it was. Right, where are we? Okay, so our signal comes in through capacitor, through resistor to here. Can't really see much signal there. Ah, I'm getting nothing here. Let's turn this up. There's our incoming signal. Ah, there it is. Just a bad connection on the probe. I can take this back down to a sensible level again. And yeah, we're getting the same distortion there. Okay, so let's sweep the frequency up. Now we're getting the same huge drop off on frequency there. So that's normal, that then. Right. That might be because of a lack of external components. Not sure. I'm thinking I might skip the first stage of this circuit. Instead of injecting into here, I'm thinking I might instead inject into here and not have power on the 19 volts. So I'm only powering through pin 9, injecting into here to see what the output of this stage is like. Possible. Or maybe just inject into there with it powered as it is now, actually, thinking about it. If I move my injection point to the base of Q804, this is the injection point. Q804 is 804 is that one there. Oh, it's a bit wide. Okay, and the base is also connecting to BC1. In fact, it's pretty much, it's where I was testing just now, isn't it? However, there is going to be a DC offset there. And that DC offset is provided by that. What is that offset? Let's find out. That would be, that's our input through there, through to there. Hang on. Oh. Hang on, I'm confused now. I am confused. I think I might have been probing the wrong place. Because we want to probe the base is on the top of there. That's the base. There. Now that's the transistor there, isn't it? That's, yeah. Now that's the base of that one there, is it? BC239. These are all labelled as BC109. 109, 108, 108. So we've got 239, 238, and these are equivalents, and 238. I assume that one, if I can see it under the dust. Yeah, it's a 238, BC238. Okay, so the BC239 comes in, so the middle pin is the base of there. The middle pin is there on that one. Right, I'm just going to put this back to where it was a sec, which is here. Okay, that's our injecting signal. There's our power, and of course this has got tangled up again. It can't help it, can it? So our incoming signal is very tiny, which goes into here is the base, which makes that the collector. Yeah, which makes that the collector of there, which is then even bigger. Right, you've got some massive clipping there. Let's take it down a bit. There we go. 2 millivolt peak to peak input. And I think I can menu sweep 1 to 20. Yeah, we can see attenuation there. Let's just slow it down a bit. Pin 9 is the main output. No, pin 10 is the main output on this. So let's have a look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be the main audio output, which is showing attenuation towards the top end, but not as much as I would expect around the 2 to 3 kilohertz. So that is, I think, okay. Which one is this? This is this is the bad board, possibly. The possibly bad board. Let's try the other board in the same way. Okay, to pin 10. Right. That's showing the same sort of characteristics. So I'm wondering if it's not these boards. I can see I'm going to have to put this all back into the unit and try it. I mean, there's always the chance that just in doing this probing I've reflowed a dry joint that was causing the problem, but it wouldn't be the first time such a thing has happened. Yeah, I'm going to see about rebuilding. What time are we at now? 9 o'clock. I've been going for 2 hours. Oh, God, it's such a lump. Okay, channel 2, put that back into here. Channel 1, put that back into here. Oh, God. Whew. Right. Spin this around. so that I can put in the important remote plug. Actually, I can stand this up like so. And the remote plug goes in here. Now inside the case is, if you can see it, if it won't stop tracking, there is this little safety interlock thing, which is just two metal prongs which cuts the power off completely when the case is open. So I need to bypass that with a cable which I don't think I have to hand. What's that one? No, I might have to just quickly bodge one up. I've got sort of the cable. It's two banana plugs with a wire on it. So what I'm going to do is just quickly cut this off. It's mains this, so I'm going to need a reasonably safe arrangement. Oh, that's not going to go in very well actually, is it? It's the wrong size of banana plug. That's awkward. That is very awkward. Is this removable? Or is it? It's riveted in, of course. How am I going to manage this then? Because without that in, I can't test it. Do I have a different type of plug? Do these work better? No. Hard for you to see what I'm doing here. If I can just, no, I can't really get any better angle on this. Basically there's two holes here. The power comes from here to one of the holes and then it goes from the other hole out. So I need to bridge those two holes, which is done by two prongs that are inside the case. And it says, oh, just bridge them with banana plugs, but banana plugs don't fit, which is great. Right. So, in order to test it, there's no other way of, because this is all riveted in, there's no way I'm going to remove this. These don't fit. It's all too, everything's too small. Can I modify these at all without stabbing my finger? probably not. If I plug it in, it's just no way that's going to work. Let's get my connectors again. See if there's anything in here that might work. It's highly unlikely. Not a chance. No, nothing there. One other box might hold a secret, but I don't know where that box is. There it is. Box with all sorts of connectors and things in it. Might have something that would work. Because this is all sorts of spade connectors and things in here. Oh, that's what I'm looking for. Just wondering if one of these bullet connectors might fit. Ooh. That's looking like a... Now, is it the inside that's connecting there? Or is it just jamming in the opening? I'm not sure. That might be working. Let's just get two of these. I'm not quite sure what happened there. My audio has died. I'm now running on my webcam audio. There's a fill-in. It'll do, I suppose. Technology, I hate technology. Especially the Linux audio system. It's just rubbish. Right, let's just yeah, if you can hear now, the audio is still really basic. I've swapped the cards over and it's not made any difference. So, yeah, I went through all that diagnosis, found no problem with it, swapped the cards over and it's not made the difference. So I was chasing a completely red herring there. So it's not the amplifier cards. Stop that. I need to switch this to, where's the right knob? Right, this is in stereo mode now. Okay, a definite difference between. Let's turn the volume up on that. Hear this? One channel, the other channel. One channel, the other channel. One channel, the other channel. So. If it's not, then what is it? Let me have a look. Changing the cards had no effect whatsoever. All the rest of it really is for recording. The input preamplifier card, the oscillator card, the recording cards, recording amplifiers. Yeah. I'm just going to go get some cotton buds. I did look at the heads, and they didn't seem particularly dirty, but I'm just going to give it a clean anyway with some IPA. And see if that makes any difference. I haven't got much off that head. Not that dirty. Not dirty enough really to make that much of a difference to the audio quality. And why one channel would buzz more than the other channel, I don't know. There's quite a lot on the erase head, but that's irrelevant really. And the record head, again quite a bit on the record head, but again that's irrelevant. The play head is pretty clean, but then it's all on the other heads, so yes. Let's see if that's done anything.
America, I don't really care. It may be that some South American from Peru is going to call me and say, "Look, that that cymbal bell should really be on the right hand, not on the left hand." But I don't care about that.
Tiny bit
I'm
of
like
dirt
one of these,
on it.
I'm a sort of scarecrow. Not a scarecrow, kind
that
of bird
amount
that
of
picks
audio.
and chooses and steals and robs and pillages and put it all together in the back of my brain, and out comes some drumming.
I'm surprised.
And I'm not an ethnomusicologist, and I don't really care about that. In fact, the electronic drums I use aren't. They've been screwed around with a lot. They're not necessarily exact replicas of anything. I've changed them. I've made their pitch do different things. I made them go up and down.
It still is more interesting and more satisfying for you now to play that than to play.
Right.
What you do is play tunes and chords and melodies. So
However, I'm still thinking there is a problem. Because I'm only really getting it out of one channel. Although, yeah. Actually, is that right? Let's look in the mono.
as I play a pad, yes, you hear the sound of a drum, but you also hear the sound of the keyboard. And some sort of the chordal side of it becomes very important. Yeah. So I have a hybrid really between drums and keyboards.
Okay, nothing on the right
Does
or on the left.
Does this cause rancor in the ranks? Not at all, because the band was configured so that the keyboard player, who's called Django Bates, also doubles beautifully on E-flat tenor horn. And when he stands up to play that, then I can cover a chord. You see, Very talented young player.
That sounds right, actually.
I was thinking, no,
After all that,
burst into tears in the corner of the studio.
Django is very talented.
after all that, it was just a matter of cleaning the heads. No, I don't believe that. Well, you live and learn, I suppose. You live and learn. It seems like it's working at the moment.
What do you like to listen to?
Have to
when you
keep those heads spotlessly clean.
Oh, I listen to lots of stuff. I'm very soul music.
Clean them after every usage. One of the problems with these old recordings is the surface does shed. It's called a sticky shed syndrome. It's where the tape delaminates and the surface separates out from the actual substrate of the tape.
and cakes up the heads like nothing on earth. So, yeah, I guess basically just make sure that after every tape, pretty much, the heads get cleaned. Just a cotton bud and some isopropyl alcohol. But yeah, that seems to be fixed there. Let's rewind. I guess I'll put it back together again and well, call it done. That sound like a train is because the reel here is on an adapter because this spindle is too big for this unit, so it's got this adapter hub in the middle, and of course it wobbles on it slightly, and when it's in the vertical position it all spins it around, and gravity fights it. But no, these Revoxes are really nice units. Very well built. That's the end. So now to put this lot back together again. I can find all the parts on my desk. Yeah, I want to... see if I can put the front cover on while it's not in the box, so that I don't get bits all over my pillows, because this should all clip on to the main chassis. There's quite a lot of sticky shed all over the inside of here. So it could do with a bit of an extra clean actually before it goes back in the box. Such a weight. Quite a bit of old bits of tape down in here, and telltale signs of sticky shed on the pinch roller here as well. So I shall give that a clean. Black straight away. Yeah, look at that. like ink once it gets dissolved by the alcohol. Yeah, should be doing this with gloves on really. In fact, I might use some paper for this. Disgusting, isn't it? Ugh. It's everywhere, this stuff. Ugh. Right. We're almost done. There's still thick black coming off it. And all over my fingers. Yuck. Do for now. A bit more of a clean of these. And there. Caked up. And now the fun one. The capstan itself. This is thick with more sticky shad. Black gunk. Quite a hefty flywheel on this. It takes a bit of effort to turn it. There we go. That's looking reasonable now. Let's put the front panel back on. Make sure these are lined up. Oh, buttons. Buttons. The buttons are down here. Record is at that end. All the others are plain. Getting this back on is fun because these buttons don't like to line up. They're very floppy. There we go. Clip, clip, and 2 screws. that. Right. I've got 2 screws for the back plate. Right. I wonder if I can get this on without having to lie it face down. Let's take out the remote plug. Oh, I think I have. Let's put the screws in underneath. Yep, they're fitting. That's lined up right. Just need to put the knobs on. Mono stereo one with a volume. We've got the EQ and balance. There's the power. The power one actually, power one disintegrated when I was doing it originally. So it's actually a 3D printed insert that I created to go inside the original aluminium shield. Fits perfectly, works well. 2 recording levels. Where's that last one gone? Come back, where have you gone? I shall find that in a moment. Buried under wires. Too many wires. I've got solder wrapped around everything as well. What is it with wires and tangling? I think quantum physicists could learn a little something from wires with their quantum entanglement. think wires are naturally quantum entangled. Right. More wires. Too many wires. I hate wires. Well, I think must be underneath. Found it. It had rolled underneath the tape recorder. Right. That's all back together. Oh! Got myself a hernia lifting this thing up. Okay. Let's check everything's working again. No, cable. Move the light down. Yes, I move this over a bit. Just screeches. Come on. Right. This is the adapter I was mentioning, because the center spindle is far too big, so that goes in the middle. It came with the unit, so it's not a hack or anything. It's an official piece of kit. But of course, it's so old. Its tolerances are slightly out now. Go. All the way around. Okay.
For a long time, but I have always, I think, felt like a jazz musician, sort of a jazz musician in rock clothing.
I don't know who this is we're listening to.
Wending my way,
I'm a drummer, apparently.
Wending my way back to where I started as being a jazz player, really, and that's how I would like to be known now. Yes.
Are the two worlds separated by a very large wall with just a small door?
They are separated by a large wall, you know, and it's not really on the musician's side. Funny enough, the musicians are very generous. You know, a good musician is a good musician, and young jazz guys like Jimi Hendrix and rock guys like Miles Davis and the rest of it. But in terms of record shops, you know, and marketing and sales and record companies, and everybody who commentates and generally is on the periphery of music, they need to know in simple language, is it rock or is it jazz? If it's got singing on it, it tends to be rock, and if it's not got singing on it, it tends to be jazz. And that's all there is to it. You know? And that's very simple, everybody understands that. Which makes life quite difficult for us players, but we try to work happily within that rather confining kind of split.
And is the business of drumming a different thing? Is it a different animal if you're playing jazz and if you're playing rock?
Yeah, it is really. It is really. The rock groups that I grew up in the 70s and 80s were very imaginative places, however, to be. And you could do all kinds of interesting things on drums, which I tried to do. However, as the 80s moved into the 90s, you know, and it became kind of an automated world, and one of Madonna and Kylie Minogue and that kind of thing, there's not really much room for drummers in that environment. So people like me, who are a bit peripheral at the best of times with pop music, tend to get pushed out of the side, or pushed back into the more creative areas, which would be, in my case, jazz.
You say that the late 80s, 90s became automated as far as rock music, pop music was concerned. But you managed to encapsulate a certain amount of automation yourself and deal with it creatively, have you not?
Not quite. I know what you're getting at, which is that my current band is based on an electronic drum set. Big difference, however, if I could just mention this, between electronics and automation. That I use electronics very live. The point is that, you know, I play pads, I hit them with flesh and blood, and I make the sound come out of this pad. The electronics I use to store the sound, just to give me a lot of colours instantly, so that I can instantly go from being a Moroccan drummer in some seedy bazaar to playing a kit of pitched finger cymbals, to playing a kit of thundering great big African drums. I can do that through technology. That, however, is not automation. Automation, the way I use it, is when you press a button and the Madonna show starts, or Michael Jackson starts, where the stage performance is largely what we call sequence, which is you press a button and it all works, and there isn't that much live playing. That's quite different from Earthworks, which is my current group, where we play with electronic percussion, but very much live.
When you access a sound, say you say that a kit of huge drums, now has the sound of a huge drum
So if this is
entered
Earthworks
into
and it's the
chip,
drummer,
the
this must
technology
be
at some point?
Bill
What you are
Bruford.
accessing is the sound of a real drum.
Correct. I'm accessing a photograph of a real drum, yeah, an oral photograph.
And does that oral photograph have the depth, the beauty, the sparkle that will satisfy you, that it is close enough to the original so that you don't hanker for the real thing?
No, I don't spend a lot of time hankering for the real thing, because I'm not trying for the real thing. Music now is too global for us all to worry about being some kind of, in some sense, industrially or culturally correct. You know, I don't care whether or not I'm playing an exact, you know, Naniga rhythm from South America. I don't really care. It may be that some South American from Peru is going to call me and say, "Look, you know, that cymbal bell should really be on the right hand."
I think that's enough for that for now. I will call that fixed. After all that diagnosis, which was fun in its own right, it turned out to be dirty heads after all. I was not expecting that, given the nature of the problem and the symptoms that we're getting. We've still got the symptom of one channel reacts more to noise than the other channel. When you actually touch the head, but it doesn't seem to impact the audio at all. Well, it's been 3 hours of tinkering and exploration with no real cause found for anything other than dirty heads. So, well, if I'd have started out with the idea that I had briefly to just swap the cards and see if the fault followed the card or not, which I was toying with that idea but didn't. If I'd have just done that, I'd have gone straight on then to heads, and well, it would have been a boring video. It would have only lasted 10 minutes. As it was, we got to delve into those audio cards a bit without sort of finding any problem, any real differences between them. It did kind of point to the problem being elsewhere. And then when I did try and swap it over, it didn't follow the cards, so that sort of bore that out. So anyway, I hope you found this a bit informative and enlightening in diagnostic techniques, but, well, a bit disappointing that we couldn't actually find a problem other than, as I say, just dirty heads, which I was actually surprised at, to be honest. Still, thank you for spending the time to watch this far into the video. I've got a couple of interesting things lined up from the same source as this. I've got an old ITT transistor radio to have a look at. It's bent and broken aerial on it, but that's an ITT-KB. Lots of writing on the bottom here, tells you all about the batteries, all in German. For battery operation only, remove exhausted batteries immediately. So hopefully there's a certain amount of corrosion in there to deal with. That's going to be next Monday's stream, I believe. There's also this little, camera catches up with me, this little transistor radio from Perdio. It's got an interesting backstory, this one, which you'll have to tune in some other time to catch. But I think you'll be interested in the backstory of this little radio. I've also got a more modern thing here. This is a more modern DAB radio to have a poke at. Again, the antenna is kind of messed up. But I mean, this probably just needs a bit of a clean up and then it'll be working again, I would imagine. Nothing really needs to go wrong, just a couple of chips, power supply, an amplifier, that's about it. These modern things are pretty inconsequential inside. Most of the weight of this will be the speakers. So yes, that's what we've got coming up in the next couple of weeks. So you can find my videos on YouTube, you can subscribe on there, you can follow me here on Twitch. I've got a Discord channel you can join in the chatter on. So yeah, swing by and say hello, and tune in next week on next Monday at 7 PM British Summer Time for the next exciting instalment.